Hello there guys, welcome back to another epic inexorable maths video. We've got an integral here. I've drawn the box in a way where it makes the integral look like it has a big forehead. I don't know if anyone understands what I mean by that, but I just feel like the integral has a big forehead because of the way I've drawn the box. I don't know guys, I don't know. Anyway, we're doing this integral. So this is an improper integral, okay? And again, it might not be obvious why it's an improper integral because well, the limits are just 0 and 2/3. They're normal numbers, neither of them are infinity or anything like that. But actually, if you plug in 2/3 into this integral, you end up getting 2 on the denominator, 2 minus 3 times 2/3. 3 times 2/3 is the number 2, and then we have 2 minus 2, which is 0. Square root of 0 is still 0. 1 divided by 0 is undefined. So we can't plug in 2/3 to this integral. This function, we don't necessarily know what the function looks like because it's a bit complicated, but actually it will have an asymptote when x is equal to 2/3. So this is an improper integral for that reason, okay? So half of the battle is just realizing, oh my God, it actually is an improper integral. Okay, let's just go in. So there's no issue with 0, that's completely fine. And there's no issue with any value in between 0 and 2/3 because the only vertical asymptote on this function, without even drawing it, I'm not going to draw this one because you wouldn't be expected to know what this graph looks like, so why would I draw it? It wouldn't be how you do the question, right? If I was to draw it, you go, okay, great, but how can I replicate that in an exam? Well, you wouldn't be able to because it's quite hard to draw. So I'm not going to draw it in this video. I always do, but I'm not going to in this video. So we're going to rewrite this as the limit as t approaches 2/3, okay, of the integral from 0 to t of 1 over the square root of 2 minus 3x. Okay, so again, we're just going to let t approach 2/3, but not actually equal it, and then we can get the area like this, okay? So let's just do the integral completely normally. So you can do this however you want. You can either use the reverse chain rule or you can use a u substitution. It's completely up to you. What I might do is I might use a u substitution here and I'm going to let u equal 2 minus 3x. So the way that I would do this, because we also have limits of two kinds, we have the limit as t approaches 2/3, but we also have the bounds on the integral, and when you do a substitution, it changes those bounds. So let me just talk you through how I'm going to deal with this as we go through it, okay? So I'm going to rewrite the integral, and I'm leaving the limits in terms of x, okay? So I'm going to say that x equals 0 and x equals t, and then I'm going to do my little substitution, okay? So maybe over here I'll just say, you know, let u equal the most obvious thing, which is 2 minus 3x. So that means that du dx is minus 3. So that means that du is minus 3 dx. So that means that dx is minus 1/3 du. And we're going to plug everything in. So we have 1 divided by the square root of u, and dx is minus 1/3 du. But I don't really want to change the limits as well, because some people, when they do a substitution with limits, when they do definite integration, they will change the limits from x into u. But I don't really want to do that because I think it will make the question more complicated because we have t approaching 2/3, and if we start messing with this, it potentially could get complicated. It's not that bad if you do want to do it, but it's just my personal preference, okay? So, but you'll see how this gets resolved in a moment. So if this isn't the way that you would normally do it, do not worry. You'll see how it comes together very shortly. Okay, let's just do a step where we rewrite things. So again, we still have x equals 0, x equals t. I'm writing x equals 0, x equals t just to remind myself it's x, not u, okay? Because you might forget potentially, but you don't have to write x equals 0. You could just do 0 to t, that's fine. 1 over the square root of u is u to the minus 1/2, and then we have minus 1/3 here. So overall we have minus 1/3 u to the power of minus 1/2 du, okay? And then maybe I'll come over here. This is the limit as t approaches 2/3 of, and then I think at this point we can do the integral. So what will this integral be? Well, u to the minus a half, let's just do that separately. So minus a third, I'm just going to put it here. And then u to the minus 1/2, what will that integrate to? Well, we need to add 1 to the power, so u to the power of positive 1/2, divide by the new power, okay, like this. And again, the limits are 0 and t, but they're x limits. X is 0 and x is t. So we can't plug these values into this function. First, we have to put the u's back, okay? So maybe I'll just make some space. It's going to get rid of this. We have a bit more space up here. Oh, so just coming up here, guys, new line. So now we're going to have that this is equal to the limit as t approaches 2/3, open bracket, and actually, let's not open bracket it just yet. Let's actually, replace the u's with the x's again. Okay, so we have the same thing. I'm just going to maybe simplify it. So dividing by a half is the same as timesing by 2. So I'm just going to put a 2 up here. So we've got minus 2/3, and then u to the square root of u, basically, the square root of u. But what was u? Well, I rubbed it off, but to be fair, u was 2 minus 3x, okay? So the square root of 2 minus 3x is here. And these are from 0 to t. Okay, so hopefully that makes sense. Amazing. And then we just start plugging things in. So first of all, we have to let x become t. So minus 2/3, the square root of 2 minus 3t. And then we subtract the other bit, which is negative. So negative 2/3 times the square root of 2 minus 3 times 0, so just 2. Square root of 2, like that. Okay? And of course, we can simplify this. So this is the limit as t goes to 2/3 of minus 2/3 square root of 2 minus 3t plus, and I'm going to write this as 2 root 2 over 3. Okay. And guys, we're basically there because the final step is to simply let t be the number 2/3. So we have and we don't need to take the limit anymore because we're going to let just t equal 2/3. And we just get t being 2/3, we have minus 2/3 times the square root of 2 minus 3 times 2/3, like this, plus 2 root 2 over 3. But guys, what is going on here? Well, we have minus 2/3, square root of 2 minus 2, plus 2 root 2 over 3. So this is 0, isn't it? And the final answer is 2 root 2 over 3. So this integral is equal to 2 root 2 over 3. Thank you guys so much for watching. I highly appreciate it. And I'll see you in the next video. Cheers.